over to you.
Thanks, Mariam. Good morning, everyone. Yeah, so let's just dive right into it. Can everyone see my screen? Okay, great. So we just wanted to start by being reminded of, excuse the background noise, of our group goal that we got set. There were so many great insights and ideas that were shared. So what we wanted to summarize it into a slide over here. And so I'll show you now in the Google Classroom, but there's, in case you wanted to add your thoughts, continue to add your thoughts. You can do that. There's a post now in Google Classroom with this that you can share. So just a reminder, we're going to be posting this at the beginning of every session. So we just remind ourselves what is our group goal that we had set together. So I will put this in a chat. So I know what we noticed is when we added all of your emails, some email addresses bounced back. That could be because maybe you used a school email, or the kind of maybe the email account you have doesn't fit with the Google Classroom the way they have it set up. But actually about 70 of you already joined the Google Classroom. So I was really happy to see that it is working for many of you. But what we're going to do now is, if you have not had access to it, if you can just try this link once more. That would be great to see. So if you have tried it and it didn't work, or you didn't get an email from us, it's because something bounced back. So please try this link, see if that works. And if this link still does not work for you, what you have to do is you have to just manually put in your class code. And you can do that by going to the Google Classroom link here. And then you have to create basically great. Okay, so the link worked for some of you. To just input your information. If you don't already have a Google account and your current email address is not working with Google Classroom, it just might mean that you have to just create one new one for this summer. So you can do that. There's a screenshot here of what that window is going to look like, and you click join class, this little blue button, and then you put in the class code that's here. Okay. Just in the interest of time, and instead of waiting for all of you to try it, why don't you try it? If you have issues, you can email us at the end of the session, or you can try it today. And then at the end of today's slide, there's going to be our email address once more, just to remind you. So let's do that. So when you go into the Google Classroom, this is what it looks like. I would say always the stream is basically like a live updates page. So whenever there's an update, you will see it on this main page. But in order to see kind of the order of the weeks, you go to classwork tab here. And then on my screen, you're going to be seeing more things that hasn't been published yet, because we want to stay focused on the weeks that we're on. So we're going to be releasing different posts as they come. So you see here the welcome, our team introductions, and you'll see our syllabus and a summary of our program. Story map resources, of course, this is just to get us started, but it's going to get built out much more as the weeks go by, and as Mariam and Anela share more information and our speakers share more technical know-hows and little tips, we're going to be adding them there. It's a little bit background of all the different partners that are putting this together. And then this is kind of now where we really get into the content, week 1. So we have some information about the guest speaker, some activities that you can do, and you'll notice here is where we have our group norm. Is this not working? Nope. So here, I had to click my edit button to get in, but you'll see a screenshot of it. And then if you didn't get a chance, this is a short answer. So from your side, this is posed as a question. So you can input your different thoughts, and then it will come up at the bottom of this post. So we can keep each other posted that way. I see few of you have already done some suggested activities here. When something is mandatory, we will say it in the live session. Otherwise, they are additional resources and things to activities that hopefully are engaging for you that you can do throughout the week. And then each week at the end of the week, so for example, today is the second session of the week. We'll post the Zoom recording and all the slides here too. So I'm gonna just cut it short there because we do have a lot of other content to cover. So that's like a very quick run through of it. And then you can email the program team if you have questions.
Thank you so much, Hayan. And yeah, as Hayan mentioned, either, let us know if you have any quick questions in the chat or feel free to email us after the session. So without further ado, I will hand it over to my colleague Anela. She is the GIS analyst and developer on the SDGs Today team, and she has a really exciting presentation on the fundamentals of GIS. Afterwards, we're going to tell you how you can access your ArcGIS license and account. And then if we have time, we might jump into the link between the SDGs and geospatial information, and then we can open it up for a Q&A and discussion. So Anela, over to you.
Great, thank you. Hi, everyone. I'm very excited to teach you all about one of my favorite things, GIS. Let me just do some screen sharing. And okay, can everyone see my screen? Good, okay, great. Okay, so you may or may not have already heard about what GIS is. It's basically mapping, and it stands for two different things. The first is geographic information science, which is the actual field of GIS. And then there's geographic information systems, which is the software and the programs and the sort of way that you use mapping tools. So one question that I get a lot when I tell people that I work with maps is, we have already mapped everything in the world, like what is your job, but then I sort of have to tell them it's more than just mapping places, it's about mapping different phenomenon on Earth. So one example that I use is in the US right now, there are going to be a lot of elections happening, and the newspapers show a lot of different election maps. So in different counties, how people have voted and things like that. So yeah, it's not just mapping where rivers and countries and things are. It's a lot, there's a lot that you can do with GIS. With that, there are a lot of different uses. I have a few listed here. Weather and climate is probably one that we'll use a lot this summer. People also use it for things like vaccine distribution. During the beginning of the pandemic, people would map where people were getting infected and figuring out the amount of vaccines they had and where to distribute them. And another example is solar panel installation sites. So figuring out the best place to install solar panels for the most amount of energy and things like that. So as you can see, there are many different uses, and that means there are many kinds of maps. So how do you actually locate features on Earth? We use what are called coordinate systems, which you probably have already learned about in your math classes. But in the context of GIS, there are two specific kinds of coordinate systems. And I'll go through both of them. But in general, geographic is basically the 3D version of a coordinate system. So it's how to locate features on Earth as it is on a globe. And then there's projected, which is sort of the 2D way to locate features on Earth, where you sort of take the globe of Earth and you flatten it out, and you figure out where things are that way. So the first is geographic coordinate systems. You probably have heard of latitude and longitude. That is what a geographic coordinate system is. So latitude, I remember it as latitude is flatitude. So it's all of the lines that are horizontal on a globe. And what it is actually is if you go to the center of the Earth and you make a line to the equator, the angle that the location makes from that line is your latitude degrees. And longitude is sort of the opposite of that, where again, if you take the center of the Earth, point a line to the prime meridian, the place that you're locating on Earth, if you make an angle there, that is what the longitude angle is. But we probably don't need to worry about coordinate systems now. I can talk about that a little bit later. The other is projected. So as I mentioned, it's if you take the sphere of Earth and you sort of cut it up and lay it flat. So it's going from a 3D surface to a 2D surface. And I like to say that it's like peeling an orange and laying it flat. I think a lot of people in intro to GIS classes will actually like do this where they draw out the Earth on an orange and then they peel it just to show the different ways that you can make a map projection. So here are different kinds of map projections. The one that you're probably most familiar with is the Mercator projection. So that's the one on the top left. What that does is it preserves direction. So that's why a lot of people know that kind of map, because if you're navigating somewhere, you can go from point A to point B, and that's exactly where you go if you go in a straight line. But there are also other kinds of projections. And you can see that sometimes it'll distort the sort of shape of countries. So in this one, you can see that the countries are a little bit smushed. But then there are also projections that are a little funky. You know, there are so many different ways to, again, peel an orange and lay it flat. So that is an interesting thing to think of when you're thinking about maps as well. My favorite projection is the Spielhaus World Ocean Map. So it focuses on the oceans. It's if you sort of turn the globe towards the oceans and then lay it flat. So you can see like this is Antarctica, and then these are all of the countries and the land surfaces around, but then all of the blue areas are all of the oceans. And you can really see that the oceans are really all connected to each other in this map. So moving on to the two different kinds of data that you can have in a geographic information system. One is called raster. So that's this sort of grid here. What it is it's sort of like a photograph. So in pictures, there are different pixels, and each pixel has a different value that corresponds to a color, and that creates your image. So in a raster data set, it's similar where it's a gridded surface. So it's all of these different cells or pixels, and then each cell has a specific value. So in this example, you can see that the darker greens all have a value of 1. So maybe that can correspond to like a forest area or something like that. I don't know if you can really see the numbers here in this blue area, but they're all 4s, and they might correspond to something like a lake. And 2 and 3 can also mean specific things in this sort of map. An example of this is temperature. So if you see like global maps of temperature around the world, you'll notice if you zoom in a lot, you'll probably start to see little squares and they're all different colors, and those are all the grid cells that make up that data set. The other kind of data, which you probably will be working with most, is a vector data set. So vectors are points, lines, and polygons. Points are the coordinate points on a map. The lines are if you take those points and you connect them. And then polygons are if you take those points and you sort of enclose an area with those points. So vector data is very useful because you can also have what's called the attribute table associated with the vector data set. So you can store different information in this kind of data set in a table. For example, if these two polygons were different countries, the data in that table would be what country each of the polygons are. And then as examples for points, examples are like school locations or hospital locations, any sort of points of interest that are on a map. Line GIS data sets can mean things like roads or rivers, and polygons, as I mentioned, could be something like countries or state boundaries, or areas of lakes and things like that. So it's important to note that these two kinds of GIS data can be interchangeable. It kind of just depends on the kind of analysis that you want to do. So you can see here, just displaying points, lines, and polygons as their own vector data sets. But if you put them on a raster grid, you can also sort of display those points, lines, and areas on a grid itself too. So again, it depends on the analysis you want to do. You probably, again, will be working mostly with vectors. So this isn't a very important topic, but if you are interested in learning more for your project, you can let us know and we can help you out. So I just talked about data within a geographic information system, but now I want to talk about actual features on Earth and how to sort of classify and map those as one of those two different types of data sets. So on Earth, a geographic feature can be discrete. In this example, it basically means that there is a specific location, a specific area that the feature is in. So here you can see that there are what are probably roads. Those are discrete because they are just lines, and you know on the map like where those are, and you can draw them out pretty easily. There are also, I think these are like campsites, and there's a hospital point. Those are discrete features also because they are just specific points on a map. And this sort of lake is discrete as well because it has a specific enclosed boundary, and you can sort of draw out that boundary. So that is a discrete geographic feature. However, features on Earth can also be continuous, which means that there isn't really a start or end, and the values throughout that feature are different. So, for example, in this image of topography, you can see that every point in this area has a different elevation, and they're expressed as the different colors in this map. So if you point to any one of these locations, it'll have a value for the elevation. Whereas in a discrete data set, if you point to any area, unless there's data there, you won't get any values. So now I'll go through some examples of discrete and continuous features just to sort of nail the point about how to map them. Coral reefs, they can be discrete features because they're all different points on this map. They all have a specific location of where they are on the map. Another discrete feature is something like dump sites. So again, in this map, they are all specific points throughout the US where oil spills and waste sites have been. So these are discrete because, again, they all have specific locations. Whale tracking is another discrete feature. So you can see, you can sort of track where whales have traveled to around Hawaii here. They're discrete features because, again, there are specific paths and then there are specific start and end points. So an example of a continuous feature, I mentioned global temperature before, but an example is sea surface temperature. So you can see on this map, every point on the ocean has a specific temperature that corresponds to a different color. So that is an example of a continuous feature. Now, I sort of have a trick question for everyone. If you want to unmute yourself or say in the chat what you think this question is. So do you think that sea ice is a continuous or a discrete feature? Shreya, do you want to answer?
I think it's a continuous feature because it's not really in one spot all the time. It'll keep moving as the water around it melts.
Mm-hmm. Does anyone else want to answer? Daniel?
I think ice is a discrete feature because like it can like melt and it's very like unpredictable.
Shreyan, would you like to say something too?
Yeah, even I thought it was some discrete feature because it can melt and move around. But it's like depends on the point of time. If it's in winter, maybe it's a continuous, and maybe during summer or times it can melt, it's discrete.
Yeah, that's a good point too. Nihal?
I think it can be both discrete and continuous feature because, for example, in some areas it's both summer and winter. So we can use discrete data to show when it is melted into water again and it becomes ice again. And for some areas like the Antarctica, where it's completely filled with ice and it shows where ice is in that area.
Yeah. Gianna, would you like to say something?
I think it could be both continuous or discrete depending on the region. So if it's like up north, it would be continuous, but like in north towards the equator, it would be discrete.
Sarah?
I think that it's a discrete feature because you wouldn't really find it in many parts of the world, maybe like near the north only. And it's probably gonna it might melt, so then it's not gonna be like a lot.
Yeah, so it seems like a lot of people think it could be continuous or discrete. And maybe I sort of alluded to that when I said that this is a trick question. And it's interesting that everyone is talking about the location on Earth. I think it's important to know that the location itself isn't a factor in if something is continuous or discrete, but I know that you have also said that it could be because of the seasons and things like that. So let me just move on here. Sea ice as a continuous data set could be because of the different concentrations in an area. So as some people mentioned in the summer time, the concentrations of sea ice might vary. So this might be more of a continuous data set because in certain areas there might be more sea ice, and in other areas there might be less, but there are also a lot of areas that are in between. And then sea ice extent itself, so the actual area that the sea ice covers can be a discrete sort of feature. So you can see like here, the red areas have less ice, and those are discrete because they have finite, like specific boundaries. And the blue spots again have more ice, and those have specific boundaries. So yeah, good job everyone for thinking about the differences in how to sort of display sea ice in different ways. We're going to move on to using AI in GIS. So I know that AI has become sort of a hot topic these days, but I think it's interesting to know that AI actually isn't very new in the field of GIS. There are different sort of methods of using AI and machine learning within map analysis. And these are some examples here. So this photo is a satellite image. So it's an image from a satellite taken of the Earth's surface. And this group of researchers used AI to figure out which places in this image have buildings. So you can see all these little yellow rectangles are places where there are buildings in that image. I won't go too much into detail. Yeah, thank you, Malik. Yes, those are all buildings. I won't go too much into detail about how people actually do this, but it's the same method in AI of using training data. So what people will do is take different satellite images and sort of create their own training data. So they'll take this image and actually outline themselves where the buildings are, and then they'll feed that training data into an AI or machine learning system, and then say, can you find sort of like the rest of the buildings here? Other uses of this are things like areas of tree cover. You also saw satellite imagery in the sea ice data set. So there are a lot of different ways to use AI in satellite imagery. A lot of people also use AI to automate some of their analysis tasks. So you can sort of ask ChatGPT, I want to use a specific kind of code, and this is what I want the code to do. Can you sort of create the code for me? And then the generative AI machine, their ChatGPT, will create the code that you can then use in your own systems. Another use is actually correcting errors in data sets. So, like human collected data can sometimes have typos, or it could have duplicate entries and things like that. You can feed a data table into an AI and try to figure out how to correct any of those errors. And then the last use that I'll talk about is making predictions about the future. So this is kind of similar to detecting specific items in satellite imagery, where you can say these are all the different places I think schools should be built in a specific area. And then you'll give the AI a new area to look at and then ask that, like, where new schools should be built there. And again, many types of maps, many different uses. You can use this for deforestation, again, different areas of different land covers throughout Earth. So, hold on. Okay. There are a lot of different positives and a lot of different negatives in using AI for GIS. I think it's important to think about the way that you're going to use AI and the way that you're interpreting the data or the output of it. But in terms of positives, AI can be really helpful in automating long tasks, so saving time. You can also use any of those methods to sort of make data-informed decisions. So again, like where schools should be built, that sort of output can be really helpful for people to make an actual decision on where those schools should go. And it can lead to more accurate classification and analysis of imagery. And again, this all depends on the training data. So that sort of relates to all the negatives that AI can have. So the first, it's easy use or plagiarism. I taught a class last semester where one of my students, I realized, was plagiarizing their final project. And so I will say it is, at this point, it can be easy to tell whether you're plagiarizing with AI or not. I think it's really important to use AI as a tool and sort of make your own writing and make your own assumptions and results from it, and not just use everything that is outputted. Because over-reliance on AI as a second point might not be good, because it might be inaccurate, again, due to whatever training data it has. And I'm sure you've seen in sort of generative AI outputs, there can also be the spread of misinformation. So the ability to falsify images and videos with generative AI is something that I know a lot of journalists are talking about today. There was an article in the New York Times a few weeks ago that I saw, and it was sort of a quiz, and it had different images of people, and you had to say whether you thought it was AI generated or not. And if you can find it, I think it really opened up my eyes, because I thought that I would be able to figure it out pretty easily. And there were a few where it was pretty easy to figure out if it was AI or not, because, you know, like an ear in the person's face looked weird, or like the shoulder was like a little, the things weren't even or something like that. So it can be pretty easy to tell, but also it can also be pretty difficult too. So I think it's really important to take AI right now with a grain of salt. I think this summer you probably won't be using too much AI, if at all, in GIS, but we thought it was an important topic to cover. So here's another discussion question. How does AI play a role in your life? Does anyone have any specific examples? Shriyan?
So I know a lot of people like classmates who used AI to help them with their studying or like to gain information for research tasks,
Mhm.
and to make and they also sometimes use the AI to make their own information sound better. So AI, a lot of people are using AI, so it like helps them develop or increase the proficiency or quality
Mhm.
of the work they created. And
Mhm.
what we could add to the lists maybe is that when people use AI, they never know if it's outdated information or if the AI is even trustable and if it's made by a proper source.
Yeah, that's a good point. Yeah, and again, that goes back to the inherent biases that there are due to training data. So again, if the training data that's used is very old, it might not be an up-to-date sort of result from that. So yeah,
Yeah.
thank you. Bernice?
Yeah, I thought that I use AI for like if I don't have an information that can be searched from Google, I'll just use AI because it's actually really helpful sometimes, or when I'm generating notes or when I'm trying to use a tool, it can just be very helpful in that sense. That's something that Google or another search web tool cannot provide.
Yeah, that's a good point too, is we, as our team in our Zoom meetings, we've been sort of experimenting with different AI tools to take notes, as you said. So are there all these different sort of AI tools that you can use in a video call that will sort of output notes for you so that when you're in the meeting, you can just focus on the meeting and not have to worry about the kind of quality of notes that you're taking. So yeah, that's a good point too. Salma?
I usually rely on AI when I'm trying to research certain topics that are hard to come by on the internet. And with the help of the example ChatGPT, I can find more informations that are in depth and helps and the ChatGPT itself helps me access that information more easily.
Yeah, I feel like a lot of the AI machines these days, they can sort of be like an encyclopedia of data and topics and things like that. So it is really useful to sort of look for data topics that you don't know that much about in an AI. Shreya?
The way I use AI might be a little bit controversial, but I like to use it as an image generator because for some projects, when you have a specific sort of vision for what you want to design your website or your poster to be, and you just can't find the image you're looking for on Google, it's really helpful to just plug text input into AI and have it generate an image for you. That being said, there are some inaccuracies with the way AI generates images, like six arms and things like that, but they're working on that. So yeah.
Yeah, that's a good point too. I do have a lot of friends who are in the creative design, like graphic design industry, and they do use AI a lot. Not just for like final outputs of creative projects, but also just sort of a tool to see how things can look and different ideas that people can use. Sarah?
I think that AI is like really like good, and like now in the modern day it's like developed so much. Like if you want to study like something and like a text or something, you can like take a photo of it and like it can generate some questions for you. But like if you're searching some things on it, it can be like a bit biased maybe sometimes, because maybe like if you ask it which is better, Apple or Samsung, maybe if like the owner of it uses Apple, they're probably gonna say Apple and like have lots of information to come with it.
Yeah, definitely. Yeah, and again, that goes back to the training data. So it's really important to know where your training data comes from and the sort of biases that are in that. Because you're right, it can lead to sort of an opinion, but only based on the training data. The other Sarah Masalka.
I feel like mostly AI is biased because of how great it's starting to become and how realistic it's getting. For example, you can see more and more pictures on generated images that look like the actual real thing, and it's starting to scare a lot of us because of how great it could become in the future, how good it could be for a lot of bad things, like, for example, framing or lying about something. And I feel like this could actually be some kind of scenarios that could happen in the future. But mostly it's used now, I'd say, for generated texts or generated paragraphs for homework and stuff. I'm not saying that this is good, nor am I saying that this is bad. I'd say that, again, it is kind of biased, knowing that it could help you learn more language and be more fluent or more polite in a text. But I'd say that of course, it should not be used too much because you want to put your human spice in the whole mix, you know?
Yeah, definitely.
And that's all I have to say. Thank you.
Yeah, and sorry if you're hearing scratching at my door, it's my cat, so I'm gonna let it in.
No, it's fine.
Okay, come on. Okay. Yeah, I think that is really an interesting point because I know that there's a lot of talk about the ethics of using AI and things like that. And I think there should be sort of a set of guidelines of how people say, like, this is an authentic image versus an AI image. I think that's a conversation that's being had now and will continue to be had in the future. Shreyan?
Yeah. So basically, in my life, I'm basically covered in AI all around, if so subtly also. For example, in my phone, right? Siri, in all of our phones, Siri, it's an AI, as well as biometric authentications which take place, whether it is face authentications or even fingerprints. They're all located on AI algorithms. And furthermore, I believe that it's not really about how much you should use AI, but I think it's where we have to set a boundary of where we have to basically use AI. For example, in defense industries, right? All of these signal jammers, and for example, these missile systems. Defense industries all over the world are advancing towards AI. So it's important to basically consider where we basically have to draw the line so that in the long run, we control AI and AI doesn't control us.
Yeah, I think that's a good point too of like the oh, sorry, I lost my train of thought. Yeah, the sort of ethics of AI isn't just like how to use the generation of the images, but like the different kinds of fields to use AI in and the ethics of like human rights violations and things like that. And it's interesting to see the different kind of ways that people will use AI. Debelis?
Yes. So hello, everyone. I'm actually going to give a little bit of an overview about my opinion. I believe that really AI is something real amazing, and it has given us a lot of positive things in our life. And as students, we can't probably go on without it because it helps us with homework and with maybe preparing for exams and sometimes trying to get in some knowledge. But the thing I'm the most afraid of is AI going to take control over us in the future. are we really going to base our whole life on AI? Because right now it becomes part of us and we can't do anything without it. If you just want to search for information, you go directly to Google. You never go to a dictionary or a book or somewhere in order to search for that. And I believe that makes it easy information, and easy information is easily forgotten. And knowledge is something that we need to search for a lot of time in order to be able to remember it. Also, it makes us kind of lazy because you could get really quick information and without needing to waste any time nor effort. So you're just sitting on the couch without doing anything and having accessible information. That's good and bad at the same time. So we gotta do something about it and try to control a little bit ourselves. And like most of you said, we need to draw a line and be more aware of how we use things.
Yeah,
use the
definitely.
positive and let the negative.
Mm-hmm. Yeah, it's interesting because when I was in school, I didn't have like ChatGPT or any AI, and so it's really nice to hear from you all about how you're using it in sort of your schoolwork and the different ways that it's sort of aiding or also like not really aiding the kind of learning that you're able to do now. Lami? Luame, are you there? Maybe they can't hear us right now, but maybe we'll go to Rania.
For me, I think that IA helped me so much. For example, it can recommend some products or some musics, movies, maybe. But it has some disadvantages, like it can misuse your personal data sometimes, and the over dependence, it can have a negative impact on your creativity. So yeah, this is my point of view.
Yeah, I think it's an interesting now of like sort of opting in or opting out of being sort of a training source. So like you said, you can feed it the sort of music that you like, and that sort of, I don't know if you guys know of the music app Pandora, but I think that was sort of one of the first music AI that I can think of. But yeah, just your willingness to share your own data, I think, is an important thing to like really think about. So I think we only have time for a couple more people. We'll go to Arwa.
Hello everyone. From my view, I think that AI gives you the opportunity to learn new things, but it has, of course, some cons. For example, from my experience, it was so funny because one time I couldn't find some information about some like authors from
Arwa, you went on mute. Yeah, you're back.
From my experience, I one time I used ChatGPT to search some authors that I couldn't find in Google. But I think it gave information about all the authors that I searched for. Also, I think that because of the ability of self-learning of AI, I'm frightened that it can control human being in the future.
Yeah, thank you. Thank you for that story too of a specific use that you were using AI. We'll do one more person, Brandon.
Yes.
I don't see Brandon online anymore.
Sorry, I got kicked
there you
out. I got kicked out.
Okay, no problem.
So, personally, I wouldn't use like ChatGPT to find information for school, just because I'd be too nervous like that the information wouldn't be correct. So instead of like, so if I need information that's a little hard to come by on Google, like I wouldn't ask ChatGPT for the information. I would probably ask ChatGPT for sources to find the information. Yeah.
Yeah, that's a good method of doing that. Yeah, definitely. I think in terms of using ChatGPT for learning during school, always listen to your teacher first, and then sort of use ChatGPT as an extra resource. And I like that idea of using it to find sources that you can then learn from directly. I think that's a great idea. I know there are still some people with your hands raised, but maybe if you want to add in the chat what you wanted to say, and then hopefully next time we can get to you. So back to GIS itself, there are, as I mentioned, so many methods and so many ways to use mapping in GIS. And that also means that there's a lot of different software that you can use. The one that people mostly use that are installed on your desktop are these. So QGIS, which is an open source software that you can go to the QGIS website and install it, and then it'll live on your hard drive and you can use it on your computer without having to pay for it. That's a really nice resource to have. Another software that a lot of people use are Esri software. So Esri creates different kinds of GIS software. The original, I think, was ArcMap, but now a lot of people use ArcGIS Pro. These are paid services, so you sort of need to buy a license and things like that. But they are also very good tools for using GIS and mapping. And a lot of people also use Google Earth, which is sort of like that 3D visualization of satellite imagery around the world. That's sort of like the 3D version of Google Maps. If you can't install things on your desktop, there are also a lot of different ways to use GIS online. So what we will be using is ArcGIS Online, which is sort of the online version of ArcGIS Pro. And what I like about the online version of these softwares is that you can make things interactive and shareable. So after this, I'll show a demo of a interactive map that you'll be able to make with us, and a dashboard, like a visualization of the data set that is interactive and fun to look at. Other softwares that are online are things like Mapbox. OpenStreetMap is also an open source sort of crowdsourcing online mapping tool. I think if you're interested in citizen science and also just mapping your own locations, I would encourage you after this to look up OpenStreetMap and then look at the area where you live and see if there's something that's not on there that you can add to it. I think that's always fun to be able to like have your own voice and say on a map what's in your area. And there's also Google Earth Engine, which is sort of like the online version of using big data sets and analyzing them in a GIS analysis. So Miriam, is it okay if I go through how to make your ArcGIS account?
Sure, sounds good.
Okay. So we will have a link to the Google form that you will fill out. It'll ask you things like your email address, and the ways that you think you'll be able to use ArcGIS and things like that. So make sure to fill that out. And then once we make your account, we will send an email with your ArcGIS credentials. So it'll have information about your username, and then you'll be able to set your password yourself. So don't forget to follow all of the instructions in the email. Create your password and then sign in, and you're done. And you can use your ArcGIS online account to make maps and the story map, which you will be turning in at the end of the summer. Is there anything that you wanted to add, Miriam?
No, if no one else has added the link in the chat, I will do that now. I think there's a question about if it's a paid service. So Anela, maybe you can just dive in to some of the details and let them know that we'll be using the online version and any other details they should be aware of.
Yeah, so we'll be hosting the accounts for you. So it is usually a paid service, but through the summer program, you'll have access to an ArcGIS online account. And you can see here, it says all ArcGIS accounts expire on August 31st. So at the end of the summer, if there is any map or story map that you want to keep, we'll just migrate them over to our accounts so that they're still available in the future. And then I just wanted to do a little demo of sort of what's next. Hold on. Okay. Can you still see my screen? Do you see the map now? Yeah, okay, great. Okay, so throughout this summer, I know we just did sort of intro to GIS, but at the next GIS specific session, I'll go through how to actually make all of these layers. So you can see the points on this map are different marine microplastics sites. And you can sort of expand the legend and see all the different kinds of collection methods that people have used for this map. And if you sort of zoom in and pan around, you can see all the different marine microplastics collection sites. And then if you click on any of the points, you can get more information about that. So this is sort of what I was talking about with vector data sets, where each point or each location also has attribute information. So on an interactive map, like you can make in ArcGIS Online, you can see all of the specific attributes there. So you can see this is how many pieces of microplastics were collected here, who collected it, and then sort of a link to the collection publication and things like that. And this is what's called a dashboard. You can also have sort of specific statistics that you want your readers to know, or your users to know. And you can also do a little bit of filtering. So for example, here, select a sampling method. I only want to see collection sites that used a Houston net. And then you can see all of these different graphs and statistics on the dashboard change. My laptop's running a little slow, but the time series here changes as well. So that is what's coming up. I think next week you'll be working more with story maps, but more on that later. And I'll hand it over to Miriam if you think there's time to talk about the SDGs and GIS. Otherwise, we can do our questions.
Sure. I can talk a little bit about the link between the SDGs and GIS. I just don't know if anyone has the slide deck on hand to share their screen.
Yeah, I can share my screen.
Okay, thank you. So yeah, I just included the Google form in the chat. So if you want access to an ArcGIS account, which you would need to create a story map and complete the final project, then you can use that form to request it. And as Anela said, we use the information there to send you an email about next steps. So please do fill out the, I'll add the link again for those who still haven't been able to access it right here. So please do fill this out by Tuesday. So we can issue the licenses and make sure that you've had enough time to go through the email so that if you do have any trouble, we can sort that out before the next training session. And as Anela mentioned, the training session next week is going to focus on how to create a story map. So if you have your account set up, you can kind of follow along with the instructors. And I think that would be a really great learning experience for all of you. So feel free to send us an email if you're having any trouble. But as long as you fill out the form, you should be receiving instructions on how to set up your account soon. So jumping into the SDGs, so as Professor Sachs mentioned on Monday, it's a set of 17 goals that was established and agreed upon by 193 member states. They cover a wide range of topics related to social justice, economic growth, environmental sustainability, and good governance. They cover a wide range of topics, and to help the countries and cities and different stakeholder groups to measure their progress against each of these goals, a group of experts came together and they identified some sub-goals, so targets, and some indicators to help countries measure their progress. So this is a set of goals that was established in 2015 with the aim to be achieved by 2030. So in order to keep everyone accountable and on schedule in terms of making progress towards the goals, having specific sub-goals or indicators to work towards helped with the development of many of these topics across different regions around the world. So if we can go to the next slide, I won't go into too much detail because this will get really technical, but I just did want to share that a lot of work did go into the development of the indicators. So a group of experts came together for each of the targets and each of the indicators. They identified a methodology. So, you know, what data sources can be used to measure this indicator? What's the methodology? How do you calculate it? So a lot of work and detail went into the development of all the metadata that's available. So if you do go to the UN website, I'll show you in the next slide, you can find detailed information about each SDG and their indicators and who's involved in the data collection process, how frequently the data is collected, And again, to help kind of categorize the monitoring of these indicators, they came up with a tier system. So there are some indicators where the methodology has been established, and countries, the majority of the countries are collecting data for it. There are some where the methodology has been established, but countries might be struggling to collect data for those indicators. And then there are some where, they're still kind of testing out different approaches. Perhaps the methodology hasn't been concretely established yet, and countries are still not collecting data for them. So if, Anela, you could go to the next slide. A couple of years ago, the UN did set up a website where you can find all the data that countries are using for their SDGs. You can find the UN's annual reports on SDG progress. So I think the 2024 report was recently published either last week or earlier this week. And it provides kind of a snapshot of where we are at a global level in terms of progress towards the SDGs. So if you're interested to see kind of how your country is doing or what kind of data your country is using, this is the platform where you can find all of that information. And again, it provides a comprehensive overview of the metadata and the methodology for each of the 231 indicators. So if we could move to the next slide. So basically, I just wanted to highlight, I hope you can take the time to kind of go through each of the goals, each of the targets, each of the indicators, get a better sense of what it is trying to kind of push the global community towards in terms of sustainability. But what you'll notice is that there are a lot of indicators that are trying to measure access to a service or access to an infrastructure. Or there are other indicators that are trying to measure environmental indicators like deforestation or plastic pollution. And so a lot of these indicators require geospatial information and GIS analysis to be calculated and measured. So for example, Anela mentioned, I think, coral reefs and other topics within the SDGs. A lot of these can benefit from features that are extracted from satellite imagery. So you can look at satellite imagery to help you understand perhaps where deforestation is happening at a rapid pace, or where plastic pollution density exists in the ocean. And you can extract that information and do analysis using GIS to come up again with a snapshot of kind of what the status of that indicator is, and that can help decision makers either at a local level, a national level, or a regional level to make decisions to reduce plastic pollution or to try to prevent coral reef bleaching, for example. This dashboard that you see on the screen is available on our website, and one of our partners developed the methodology for this particular SDG indicator, which is related to access to public spaces. So if you look at the methodology, you'll see they've used a variety of different data sources to look at how do you identify. First, how do you define a public space? And then how do you identify what tools can you use to identify that? And then how do you measure accessibility to that? So, in terms of accessibility through walking, accessibility through, different modes of transportation. So a lot of these indicators can be measured and calculated with the help of geospatial information and geospatial analysis. So if you take a look at some of the different data sets on the platform, you can read through the methodology if you're really interested to see what kind of data sources were used, what kind of analysis was used to measure that specific indicator. But the point I really wanted to highlight, and I know we only have a couple more minutes left, was that once you spend a little bit of time during this program understanding the SDGs and how they're measured, you'll see that geospatial information and analysis can play a very important role in measuring a lot of them. So to keep that in mind when you're kind of thinking through your projects, perhaps a particular SDG or indicator that you want to focus on, you can explore based on some of the material that we're sharing through our program or material that you might find yourselves, how you might utilize these skills that you're learning to present your final solution. So if we could move on to the next slide. Oh yeah, this is just an example, a snapshot of the coral reef bleaching dashboard. Again, you can find all of this on our website. And yeah, we can move on to maybe skip the question slide just so that I can go through a couple more points. Not that we don't want to receive questions, but I have a few important announcements that I wanted to share. I did notice there were some questions in the chat about the final project and whether or not you can team up and do a group project instead of an individual project, and that's completely fine. So I did notice a lot of students also mentioned on Monday that they're really excited about the opportunity to collaborate, and that we all might be facing a lot of similar challenges, even if we live in different cities and different countries around the world. So we are open to group projects. What we will ask of you, and we can go into more detail about how you can communicate that next week. But when you do submit the topic and kind of idea of your final project next week, you can also indicate whether or not you're going to do that individually or with a group, and you can list all the members of your group with your submission. So we can go over that again next week, but keep in mind that that is possible. So this is a reminder that you can also share your feedback in Google Classroom. So there are, as Hayan kind of showed you, there is space for you to be able to provide your feedback. And I believe you can also continue the discussions that we had today in Google Classroom. So whether you had the opportunity to share your thoughts or not, you can continue this discussions with your peers in Google Classroom. And my final point, if we can move to the next slide, is that we are keeping track of attendance. So we are going to use some features through the Zoom platform to keep track of students that are participating. As we mentioned on Monday, it's we understand that you might have plans with your families over the summer and might not be able to attend all sessions. So if you can't attend, 1 or 2 sessions, that's completely fine. You'll find the recordings of the sessions on the platform, and you can catch up with the material that you have missed. So I think we are at time, and that is all we have time for today. So yeah, please don't forget to fill out the Google form to request access to an ArcGIS account. And we will see you all at the same time on Monday. Thank you for a wonderful session today.
Thank you. Bye.
Bye, everyone.
Goodbye.
Thank you.
Bye.
Thank you.
Thank you.
Bye.
Thank
you.
you.
Thank you.
Bye.
Thank
Bye.
you. Bye.
Thank you.
Thank you so much.
Thank you.
Put it down. Bye. Put it down. Bye.
The phone.
Thank you. Thank you. Thank you. Bye. Thank you.